A peptide bond is a covalent chemical bond linking two consecutive amino acid monomers along a peptide-protein chain. Synthesis: when two amino acids form a dipeptide through peptide bond, it is called condensation. In condensation, two amino acids approach each other, with the acid moiety of one coming near the amino moiety of the other. One loses a hydrogen and oxygen from its carboxyl group and the other loses a hydrogen from its amino group. This reaction produces a molecule of water and two amino acids joined by a peptide bond. The two joined amino acids are called a dipeptide. The peptide bond is synthesized when the carboxyl group of one amino acid molecule reacts with the amino group of the other amino acid molecule, causing the release of a molecule of water. Hence the process is a dehydration synthesis reaction. The formation of the peptide bond consumes energy, which, in living systems, is derived from ATP. Polypeptides and proteins are chains of amino acids held together by peptide bonds. Living organisms employ enzymes to produce polypeptides, and ribosomes to produce proteins. Peptides are synthesized by specific enzymes. For example, the tripeptide glutathione is synthesized in two steps from free amino acids by two enzymes, gamma-glutamylcysteine synthetase and glutathione synthetase. Degradation: a peptide bond can be broken by hydrolysis. In the presence of water, they will break down and release 8 to 16 kJ per mole of free energy. This process is extremely slow. In living organisms, the process is catalyzed by enzymes known as peptide scissor proteases. Spectra: the wavelength of absorption for a peptide bond is 190 to 230 nanometers. Chemical reactions: due to its resonance stabilization, the peptide bond is relatively unreactive under physiological conditions, even less than similar compounds such as esters. Nevertheless, peptide bonds can undergo chemical reactions, usually through an attack of an electronegative atom on the carbonyl carbon, breaking the carbonyl double bond and forming a tetrahedral intermediate. This is the pathway followed in proteolysis and, more generally, in NO-acyl exchange reactions such as those of entenes. When the functional group attacking the peptide bond is ethyl, hydroxyl or imine, the resulting molecule may be called a CYCLOL or, more specifically, a thiocyclol, an oxacyclol or an azocyclol, respectively.